Okay, we're going to prove these two important facts that will simplify many times complicated equations. The first one, perhaps the most important, is if you have an odd function integrated over a symmetric interval like this, then the interval is always 0. If we have an even function and it's integrated over a symmetric integral, then it is twice the integral of half the interval, right? And then we have to apply this result to this, to calculating this complicated integral here. Okay, let's go first with the first part. What we're going to do is to apply additive of intervals and then split this integral into two. This one here and this one. 0 to a f dx. All right? Okay, now in this integral here, we're going to make the change x equal to negative t. Right? So we have dx is minus dt. And when x is negative a, t is a. When x is 0, t is 0. Right? So we have that. And we have f minus t. Okay? And then we have minus dt, so minus dt. Plus the other one, which is 0 to a f dx, right? Okay, now on the one hand we have minus this integral, which is the same as plus the integral from 0 to a. So we invert the limits here by changing one sign, right? On the other hand, the function is odd, so that means that this is minus ft dt, and then we have to add the integral from 0 to a f of x dx. Okay, now you can see this one, we have this integral here, fx dx, minus this minus here, the integral ft dt. And since these two integrals are the same, the result is 0. Alright? So whenever you have an odd function, so you can do this, right? You can just, if you're integrating over a symmetric interval, then the integral is 0. All right, let's do now the argument when the function is even. So everything works the same, so we have to do exactly the same change of variable, right? But then here, f of minus t is equal to f of t, right? So what we have here is twice, hang on a minute, what you have here is twice, you see, you have this plus the integral from 0 to a, so this integral here, f of x dx. Okay, so you have once this integral, twice this integral, so 2 times integral 0 to a fx dx. Okay, so that's the second result. And now the third one, for the third one, what we're going to do is change of variable. So we have this primitive, 6 to 10, the sine of x minus 8 cube dx. So it's a very complicated integral. I mean, finding a primitive of this is hopeless. But we can do a simple change of variable, which is t equal to x minus 8. And if we do that, we have 6 minus 8 is minus 2. And 10 minus 8 is 2. And dt and dx are the same. So what we integrate now is this function here. So t cubed, right? Okay, dt. Okay, so we have to transform this integral into this one, which is a symmetric interval here, and this function here is odd, because if you change t by minus t, right, you get here minus t cubed, but the sign is odd, so this is minus the sign of t cubed, and again the sign is odd, so this is minus the sign of t cubed. So this is 0 according to this result that we have proven up here.